been supernaturally disciplined, and I hope everyone really will count that unto them for righteousness. We're fortunate to come to Professor Rosing, who's not only the Professor of Geology at the University of Copenhagen, and obviously will be in the eye of the storm very soon himself, but was born, I think I'm right in saying, in Greenland, in a small community in Greenland, and has continued a very close connection with that country. Professor Rosing.
Thank you. Thank you, Your Holiness. Thank you for inviting me to speak here, and eminences, ladies and gentlemen. I'm going to talk about water, although I'm a geologist. And I have to warn you that geology is the most pedestrian of all sciences, so we are not going to see very fine graphs or anything, but we'll try to keep it very simple. But we have seen this beautiful picture of the world from space, and I guess we have seen it several times already. And we always come back to this picture. It shows the beauty of our planet, and it is also a misleading picture because it shows this watery world, this beautiful oasis for life, which it really is. But it gives us an impression that Earth is a watery planet. But if we make a cut into this nice planet, like we did here, take a little dent out of it, it turns out that this watery aspect of the planet is a very, very thin veneer just covering the surface or parts of the surface of the planet. And as you can see here, on a scale of this slide, we can't even see the oceans and the atmosphere. They are so thin that we don't see them. So every time we see presentations, they are enlarged and oversized to give us the impression that we have a very large system. And we all know the expression that the skies are high, which they aren't. They are very low. The skies is a very, very thin film. So everything that's of concern to us is pinched in between the hot interior of the planet. 100 kilometers under our feet, it's 1,300 degrees centigrade. About 100 kilometers over our head, it's minus 270 degrees centigrade. And in that very narrow, thin veneer, that's what everything of consequence to us happens. And it's a very fragile and very, very vulnerable, thin object. So what is the geologic history of this, area, or this zone that we live in? Has it been on Earth forever? And His Holiness told us in his introduction that we now know that the universe is almost 14 billion years old, that the planet itself is 4.5 billion years old, that life has been here so long. But actually, is this a stable system, and how long has it functioned? Well, people have been wondering about the antiquity of Earth, of course, through all human history. And an interesting example that involves the rivers and the water in trying to determine that was a jolly Irishman called Joly, who in just around the turn of the past century tried to calculate the age of the Earth because he said the seas are salt and the rivers are fresh. Of course, there's a little bit of salt in the freshwater rivers, and that little bit of salt is running into the ocean. And as the water evaporates from the ocean, it leaves the salt behind, and by that, the oceans becomes more saltier and saltier, and he basically established the idea of this hydrological cycle, the water cycle on the planet, that eternally renews the freshwater supply by evaporating the salt water. So he looked at the amount of salt in the ocean and the amount of salt in the rivers. This is a picture of salt pans in the San Francisco Bay. They are colored due to microorganisms, but never mind. All this is salt that is evaporating out of the ocean. And by doing that, he came to the result that Earth is about 100 million years old, or at least the oceans are, because the amount of salt that is transported by the river would make the ocean salty in about 100 million years. So that would be the time scale that would be available for everything. Of course, that was in conflict with what Darwin was saying at that time about the evolution of life. It could simply not happen in 100 million years. But what he didn't understand, our good friend Joly, was that the oceans themselves are not stable configurations. The oceans are not just sitting there through all time. Actually, what happens is that the oceans react with the rocks below them. The oceans are resting on rocky grounds. And the oceans react, and they form new minerals, as you can see here. These minerals contain carbon dioxide in the form of calcite or of carbonate, and they also contain water that is bound into the minerals. And the ocean floor itself sinks into the inner part of the Earth as time goes. And what you see here is almost like a CT scan of Earth. It's a seismic tomography of the entire planet. And you can see these big blue slabs that are descending into the inner part of the Earth. They're basically pieces of ocean floor that are plummeting into the inner part of Earth. And as they do so, they take carbon dioxide and they take water with them along into the inner part of Earth. And that cycle takes about 100 million years or so for the water to be dragged out of the ocean and into the earth and return again through emanations from volcanics. So therefore, we have a cycle that are renewing the oceans over about 100 million years. Otherwise, they would be unbearably salty and they wouldn't basically function as sustaining for life. So Earth itself is providing us with basically a scrubbing mechanism for cleansing the oceans over a time of 100 million years. That's important in terms of climate change, because that means that whatever we do, if we take a really large view on things, whatever we do, it'll be wiped out in 100 million years. Unfortunately, we cannot wait 100 million years for this to happen, so that's the reason why we should be cautious. But seen from a planetary perspective, whatever we do is really without consequence. Some of you and some of us had the fortune to go to West Greenland a couple of years ago on the past Symposium, and one of the places we went was to the place where the oldest rocks are preserved on the planet. And what we find in this place is that we have rocks that clearly are produced in an oceanic environment. We can see that 4 billion years, almost 4 billion years ago, we had oceans, and the oceans were full of liquid water, just as they are today. From measuring the rocks, we can see what the atmosphere was like, and we can see that the atmosphere had no oxygen, but it had CO2 almost in the same range as today. So when Bob showed you a graph showing CO2 in the atmosphere through thousands of years, actually you can extend that pretty much back not only millions of years, hundreds of millions of years, but billions of years. The Earth system is extremely stable for very strange reasons, but that is how it seems to work. Just to give you an impression of how old the geologic history of Earth is and how much experience we actually have with understanding the Earth system, I'll just give you this graph that shows all time. So not just a fraction of time, but this is all time. So time starts over at the left-hand side, 13.7 million years ago, and the red line down here shows you how far back in time that life took over management of the carbon cycle on the planet. So Earth geologic history has recorded almost 1/3 of all time that ever existed, and the Earth system has been a stable heaven for life for almost 1/3 of the entire existence of our universe. So it is a stable system, and as I said, I don't think we can destroy it, but we can maybe make it much less pleasant to ourselves, and that's what matters. One of the strange features of this planet, aside from water, and I think that is the reason why we are going to experience the blessing of the water in a not so long time, is that water is the strangest component we know of. In terms of chemical and physical properties, no other substance is known that is as weird as water is. Water is kind of odd in every possible way you can think of. It acts opposite to what sensible, normal substances would do. And that's probably the reason why water is such an essential component for life. And it cannot be substituted by any other substance, because there are no substance that resemble water in any way at all. So that's a really strange thing. So water is the host of life, and as you can see here, the life in the water, after having evolved for several hundred million years, or maybe billions of years, decided it was time to take a go at the atmosphere, and they invented the production of oxygen, which is an essential part to us today. Yesterday we made this breathing exercise during one of the lectures, and what we basically did was that we are inhaling waste products from some microorganisms living out in the environment. And as we inhale these microorganismic waste products, we consume them and we return CO2 to the atmosphere. But these waste products were not in the atmosphere had it not been for life. So life has been basically also for 4 billion years, have been maintaining the composition of the atmosphere and the composition of the ocean. So that is something that life is doing. And the reason why life is doing that is because life has found out how to master solar energy. If we look at how much energy is available to the entire planet, it's only 87 milliwatts per square meters. That means that it takes about a football field for Earth to have enough energy to fire just one, to have one light bulb going. So Earth is a very slow working machine. Earth is a extremely boring place, if I may say so, because it has only 87 milliwatts to work on. In contrast to that, Sun sheds 340, oh, sorry, there's an error here. I don't know how that, but 340 watts per square meter. So there is many, many thousands times more energy coming from the sun on the surface of the planet. So in reality, if you take 1 square meter of Earth's surface, the amount of energy that falls from sunlight on this square meter during 1 hour is the same amount of energy as is in the vets down to the center of Earth is spent during a full year. So the sun is by far the overwhelming energy source for everything that goes on the planet. And as said before, life found out how to tap into that energy source. And what life did basically is that they were able now, today, the biosphere on the planet, they are harvesting 300 milliwatts out of the solar energy. So as you can see, you don't need to care about all these watts and what it all means, but what you can see is 300 as contrasted to 87. It's a dramatic number. It means that life is a much stronger force on the planet today than volcanoes and earthquakes and plate tectonics and everything else that is happening. Life is the dominant force on our planet. And it is basically the reason why life is such a strong factor in determining the atmosphere, the ocean, everything else. Life is the pump that takes CO2 from the atmosphere into the ocean and so forth. So life has a very, very strong influence on our planet. So how do we see this expressed, the importance of life? And I think that's the reason why it is life has such water has received such a notable position in religious belief. Is basically because we know that we are dependent on it, and we can see that again on a global scale here, that the places where you have fresh water, particularly large rivers, that's where everybody lives. I think the most conspicuous is the Nile over to the left. I should have had a pointer here, but anyway, you can probably all see this light worm that is running down on the left-hand side of the screen. That's the Nile. If you move over a little bit, you can see the Indus just at the left corner of India. You can see the Ganges on the other side of India, and over, oh sorry, oops, thank you, we'll try to, so here was the Nile. Here's the Indus, here's the Ganges, and here's the Mekong running in these areas. So you can see where activity is basically where life is. Even today in modern industrialized world, we still cluster around the sources of fresh water, and particularly the great rivers. So without knowing, of course, but I would speculate that that is the reason why His Old Holiness have focused on the great rivers as a good, what would you say, picture for the importance of water for the sustenance of all of us. So what is now happening during climate change? And we hear that water is a threatened resource on the planet. Again, as I said before, water is a rare commodity on our planet. If you took the whole Earth and divided it into 10,000 boxes, only one of these boxes would contain water. So water is not, as we think, a very, very common thing on Earth. Earth has, again, very, very thin veneer of water, but by and large, water is a very rare commodity. And water has not been here through all time. It goes maybe 4 billion years back or so, but actually Earth was born dry. And it received water from the heavens or from space, and has been able to keep it where it was ever since. Whereas other planets, like Venus, for instance, probably got the same endowment of water, but spent unwisely either by life that might have been on Venus early on, or maybe by the absence of life. Basically, Venus lost its water to space and is now a planet that has a surface temperature of 480 degrees centigrade. And the reason why Venus has 480 degrees centigrade today is because it had what is known as a runaway greenhouse catastrophe. So at some point in time, the absence of life, or maybe stupid life, basically mismanaged the hydrosphere on Venus and sent it out into a very unpleasant future where it's still resting. So when we talk about the importance of climate change on water on our own planet, what does that actually mean? Are we losing water? Well, we can see from geochemistry that we have lost about 1 meter of water every billion years. So water is safe on our planet due to the stewardship, I guess, on collective life. There's no sign that we are losing more water than that. So when we're talking about, and this is an example that we see here, is a lake in Greenland. Greenland, to those who have been there, well, you realize it's the wettest place you can ever likely to go to. But I have never seen anything like this. This is two summers ago, West Greenland, big lakes, completely dried out. So we see this repeatedly many places, and does that mean that we are losing water? And of course, the answer is no, we are not losing water. What we are doing is that we are redistributing water in a way differently from what we did before. That's what climate change does, is that it puts water places where it didn't used to be, or at times where it didn't used to come, and that's the main problem. And I think it was it's been said several times during the various talks here, that climate change is not bringing us a worse climate or a climate that is necessarily, at least, will not bring us a climate that is any worse than we have now. It's just the problem is that we adapted to the one we have now, and everybody live in places where the water is available now. But if the water moves somewhere else, then it's very unpractical to have everybody move over there, and even worse, there might be somebody living there already who would be unhappy to see us coming. So therefore, the issue of climate change, in my view, is not that we are losing water or anything like that. It's not that we are getting into a worse climate, because climates are neither good nor bad, but we are getting into a different climate. And the rate of change in the climate is greater than anything that our cultures can adapt to, and that is what causes the problem. If we now take a look at this planet again, and take a look at these various, it seems to work in unpredictable manner. That's odd. Something is happening. Now we get some watts on here. These are the watts we have already seen. Let's see if we get new watts coming up. Well, it doesn't seem to respond to, here it is. It's basically, it's just a very slow response to, there was the contributions from okay, so here's the important part of this figure. As we saw before, life is the overwhelming power on the planet, and it is basically responsible for most of the energy translation in the Earth's system. But one thing that I think is really interesting here is these 25 milliwatts that we see down in the corner here. That is our present-day burning of fossil fuels. So regardless of whether you believe in greenhouse gas emissions and acidification, everything else, just look at this one figure and say, okay, 25 milliwatts contrasted to the 87 that Earth has as a whole to operate the entire planet. That's what we are spending in driving our cars, running our refrigerators and everything else. So it's completely insane. I mean, there's no way that you can change the balance of the planet by a certain amount without shifting the entire way it functions. Every system is going to be affected by an energy contribution like that from the fossil fuel burning. So I guess that is the bad news. But the good news is up in the other corner. That is that 340 watts per square meter compared to 25 milliwatts tells us that do we have a problem in obtaining energy for our needs? I mean, this is 25 thousandths of a watt. This is what we need, and we get 340 full watts per square meter. So I think the answer to many of the questions, and a lot of people have been studying this in great detail and by all kinds of scientific principles, there's, even with existing technologies, we can meet our energy demand by tapping into those 340 watts and their derivatives in terms of wind and hydroelectric, which are basically coming out of the same pool. So there is absolutely no reason to despair, because there is ample ways of obtaining these 25 milliwatts. And I would even say it's not cumbersome ways. I think that if we decided to start manning this planet today, we came in on a spaceship and said, okay, let's set up a civilization here, we need this and that and the other, how would we get that? Then the idea of saying, okay, we need 25 milliwatts per square meter for industrial use and everything else, how would we get that? And we would look up at the sun and then say, okay, should we get it from there where we have for free 340 watts coming down every square meter all day? Should we go out into the North Sea and drill a hole that's 3 kilometers deep and pump up some oil and send it to a refinery and pipe it in somewhere and send it out to a distribution system and everybody puts it in there? I mean, just the idea of contriving that plan, given if you should start from over again, is completely remote to me. So therefore, I think that the cheerful note is that yes, we need to act, but we actually don't have a problem. if we don't act, we might get a problem, of course. This is just a fantasy of what Earth would look like with a runaway greenhouse catastrophe. The oceans would go, the ocean floor would rust, and we would sit back with some moon-like continents that would probably be less than pleasant to live on. So with that, I would like to thank you for your attention and hope that you will believe with me that we actually do not have a problem other than our own stupidity. So thank you.
Well, no problem but for our own stupidity, which sounds like quite a considerable problem, in fact. Now, because of the superhuman restraint of the panel, we do have at least 15 minutes before our agreed and contracted time to part at 1, to get ready for the departure at 1:30. And I'll give a notice about that at the end of this session. But there's a chance for questions, real questions, you know, pithy, perhaps a couple of sentences, really opening up some of the things the panel has said. Real questions. Sir.
I would like to ask in general, you did your envisioning the next 200 years. What do you think the answer to the vision would have been if you'd done it 100 years ago in Mississippi? And I ask that because I think the values and the concerns that Americans legitimately have today on the Mississippi are very different from the concerns they had when it was a young country, a much poorer country in a different era.
Great question, sir. I think as 100 years ago, we were looking at specifically what was outside our village and not looking at it as a whole watershed. And so I think we would not be looking at a vision for the third largest watershed 100 years prior from now.
Thank you very much indeed. Professor Tucker.
Thank you. Thank you for this very interesting panel. One question for the Brigadier General, and that is, I would like to draw you out a little bit about why the Army Corps of Engineers did not really do much about New Orleans, or wasn't present in your talk, so that the protections for New Orleans were not in place in terms of levees. The other question is, when you speak about a 200-year plan for the future, as others have indicated, some of this may be underwater here, but my biggest concern was when you say that your first point was that we should provide a quality of life unmatched in the world. This strikes me as part of the usual American sensibility of entitlement to a quality of life that is unmatched in the rest of the world, whereas in fact the spirit of a conference like this would suggest that a decent quality of life for everyone is what we are after. So I would love to have your response to that, as well as the question that our French environment minister asked about why the U.S. has not yet really come forward in the issues of climate change. And I hope that Bob Carell will answer that, as well as some of the other scientists. Thank you.
Thank you. A three-part question. Let me see if I get to the first one. I think there's a panel tomorrow with the chief engineers who will be talking about Hurricane Katrina and the impacts from that. Certainly, I'm the commander that's working with the Hurricane Storm Damage Risk Reduction and Task Force HOPE. The U.S. government has given us $15 billion to put the storm damage risk reduction systems back in place in New Orleans to protect against the 1% chance of a storm. And I think you saw in today's paper in the Times-Picayune, one of those last piles were being driven on the surge protection at Lake Borgne, and I can go on for hours to talk about the work that we've got ongoing for Katrina. The third part in regards to responding to the French minister's question, I'll leave that to politicians. I would also look at as we go forward together from a community point of view. I think it gets divisive to say we've made the decision, you haven't. Why haven't you? And perhaps we should be looking towards the vision of we're all in this together. Let's go accomplish that vision. But I'll leave my politicians to respond to that question. In regards to the third one, a quality of life unmatched, I think that's each of us are looking at. Certainly, our engineers are looking at how to provide that social network that we are living every year in a better environment than we had in the past. Having the best environment in the world does not necessarily mean that it's only America's. My New York accent came out with an R at the end of America, but it's America's vision. I think it's also a global vision that we're better than we have been in the past.
The quality of life unmatched in the world is exactly why we are in the problem that we are in and deeply resented around the world for use of resources, etc. So I would simply suggest that phrase might be rephrased in a more equitable manner.
So noted.
Perhaps, Dr. Correll, since you didn't really have an opportunity to comment on things earlier, and you're not a politician either, but would you care to put your head over the parapet on this one?
Yes. Thank you, and also thank you to our French minister and his question, because it, in my view, is kind of at the heart of the dilemma that we in this country, and I think many other countries in the world, face. And I think I would just say that the issue that has been the hallmark of this meeting about rebalancing is kind of at the heart of it. I think we've relied in our country, and I'm walking into dangerous waters, but I'll do so anyways. We've had a propensity to think that the decision around the climate change and frankly many other very large-scale issues are the responsibility of the government. And I think there have been several conversations during the last day and a half that would suggest that this is not an adequate mechanism. The private sector, local citizens, Bob has just done a stunning job to tell you how they're beginning to view this within both Houston and the state of Texas, that local perspectives are in order. And I would argue that what I see happening in the U.S., because I do get to talk a lot with our political leaders, is there is a recognition that things have to happen at state and local levels. And there are now many cities around our country, many states around our country are beginning the process of asking, how do we play in this game? Because I don't know who said it, but everything really of importance has a local perspective. So we're on a learning curve. I know many of the senators who are faced with this really gargantuan task of getting a climate bill are trying very hard to do two things. One, work at this highest level, at the same time work very diligently at the local level to try to bring a stronger will, if you will, a political will to the equation. But we could learn from other countries, and I hope we really do.
Well, far from wading into dangerous waters, it appeared to me that you walked on the water in that answer, which is quite extraordinary. Another question over there.
Yes, I just want to make two points. And then ask a question. One point is that I understand that this morning the Executive Secretary of UNFCCC made an appeal at the BBC. Yes, please use the mic. Yeah, I can't hear you. I understand that this morning the Executive Secretary of UNFCCC, Eva de Boer, made an appeal at BBC to the Americans to get their act together, saying that otherwise Copenhagen would be very, very difficult. I just want to also quote what was said a week ago by the European Commissioner's chief negotiator in Brussels. Everyone is aware that all that can be expected in Copenhagen is an agreement on the broad policy, leaving scientific experts to negotiate the details in 2010. Now, in light of your presentation this morning, I think that opens an interesting question, because your presentation included the presentation of if all the positions that are being brought to Copenhagen are taken into account, we still do not gain too much. Next week, the IPCC is meeting in Bali, and I am not so sure that the IPCC is preparing a message to Copenhagen from Bali. But my question to you is, well, how could the scientific community, if there is a 2010 year, open for negotiating? How could the scientific community, more in particular IPCC, get a stronger hold and a better influence on these details, so that what has been decided in Copenhagen as maybe a negotiating round for the next year can be filled with the reality of scientific presence and not with once in every 4 or 5 years IPCC reports?
Dr. Carell.
Wow. Anybody want to join me in that answer?
Well, Dr. Schmidt does,
Yeah,
but...
good, he will. I urge him to do so. One of the difficulties for IPCC is it's an event process. It creates an assessment through a complicated and peer-reviewed and government-engaged process, but it does it every 6 to 7 years. So it's hard for the IPCC leadership, Pachi and all the others, to make any statement outside of what the IPCC has already said. And as I think I indicated earlier, the science in the 2007 report was frozen in 2005. So it's 4 years old right now. And so it's hard for that community to bring the kind of message that we can bring through a process like this and gathered by the people gathered at this and other tables like it, to try to share with you some of the more recent science that brings that process up to date. And I think we're all dedicated to do that, and I think even more so than in the past. And I know a number in this audience who are dedicated to that process. So how can we do that? And I suggest to you that the result that came up out of my ending discussion about how climate models, highly reviewed, beat to death by peer review process, can be used in the negotiation. And the model that was used to give the results to you is now in the hands of the Japanese, the Indonesians, the United States government, and many others who are actually doing their own what-if studies. And that's a way in which we in the science community with 20, 30 years of work on climate models are getting things that are more useful to the daily work of the negotiators. When the negotiators met in Bonn, Germany about, 6 or 8 weeks ago, we were running what-if scenarios every night, 25, 30 of them from various countries, asking the question, well, what if we do this and we do that, and what does that do to concentrations in the atmosphere and temperature? And out of that experience, we became clear to us that they should be able to run their own scenarios. So we have worked very hard in this Climate Action Initiative to give this climate model to each of these countries. The story in China is fascinating. They asked for it, and we agreed to do so and sent a team with the climate model and all the necessary documentation, which by that time had been translated into Mandarin and one other dialect. And for 3 days, there was a worry that this was the Americans' Trojan horse to bring a model that would make the Americans look good and the Chinese look bad. But fortunately, that's not what it was. It was our attempt to give them the best science that they could have, and after 4 days, they agreed this would be their model and that they would use it for their studies. It's only one of many ways, and I would argue the one thing that the UNFCCC process ought to do more than they're doing now, and that is include some of the leading scientists from their country on their delegations to work with them to interpret this information. Science is the foundation. You made my opening slide. It was all about foundations. If you'll forgive me, I think my model for the climate issue and for Copenhagen is to build the climate cathedral. And you build a cathedral by building a foundation first. And over time, you'll find where you put the gargoyles, where you put the altar, and the other things, which those who built the foundation may not have understood or even known about. But over time, if we build a good foundation in Copenhagen, and over COP 16, 17, 18, I think we can build the climate cathedral.
Thank you very much indeed. A final word with Dr. Schmidt.
I think, actually, just kind of following on from exactly what you said, there's a very good example in the ozone protocols. When the Montreal protocols were signed to phase out CFCs, they actually weren't sign to phase out CFCs. They were just reducing the rate of growth by a very small amount. It took them 4 rounds of negotiation before people finally realized how easy it was to phase out CFCs altogether, and that took, that whole process took about 20 years from finding the science of the problem, working out all the different replacements and all the technologies, and then the negotiations. Climate change is much more complicated than ozone depletion was, and anticipating that it's going to take any less time, despite the urgency of the task ahead of us, is possibly a touch optimistic.
So the discussion continues. We've got another line-up this afternoon, and the themes that have been raised this morning will obviously continue to crop up in various forms in the days to come. But on your behalf, I think we've had a very remarkable morning indeed of being briefed, being sobered, and being encouraged. And can we thank the panel very much indeed? And just one notice from the management. We shall meet at 1:30 in the lobby on the first floor. And for those of us from benighted cultures, the first floor means the ground floor. I think I'm right in saying, doesn't it? We'll be meeting on the first floor, or the ground floor of the main building. And there we shall board buses. We shall go and join the steamboat Natchez. We'll have a 2-hour tour, and most significant of all, we'll be witnesses of the blessing of the waters of the Mississippi by His All Holiness the Ecumenical Patriarch.